This is the last presentation on global warming as it relates to how humans are affecting Earth's radiation balance. In this part, I'm going to assume that the scientific consensus that global warming is anthropogenically caused is correct, and that this part is exploring who and where are the winners and losers. Again, I don't think it's appropriate for a professor to shove my own opinions down students' throats, but I'll tell you the obvious. My view is that we have nothing to lose and we only have a better Earth if we assume that global warming is a serious problem and we need to solve it by reducing greenhouse gases. All the things on the list of this climate summit side would be the benefit. Basically, the only losers are going to be people with investments in the fossil fuel industry. And even those won't have to worry for decades while we slowly wean ourselves off of this dependence on greenhouse gases. So that's my opinion. It's a practical one, but the scientific consensus, I'm not sure it's right, but let's assume it is here so you can understand the winners and losers. You've seen this graphic many times. The key issue, is it a trend? And we're assuming here that the trend is real. Is it a cycle? We're assuming no. Is it randomness? We're assuming no. I'll also start with a reminder that everybody on all sides of the issue agree that greenhouse gases are way up, caused by anthropogenic emissions, and that there are also buried bombs of natural sinks that could release carbon dioxide and methane into the atmosphere. Everybody agrees that greenhouse gases are way up in the troposphere. No disagreement anywhere in the scientific literature. There's also agreement that the nights are getting much warmer and that warmer nights will result in more diseases, both pathogenic diseases and things like parasites. So get ready for these nasties. Another area of agreement in the scientists is that increases in carbon dioxide in the atmosphere have caused increases in ocean acidification. When you make the ocean more acid, it creates a lot of problems for organisms that make their life shell, their bone, out of carbonate that comes from, and ocean acidification causes problems for things like corals. I'll go into detail on this later, but there is agreement that the increase in CO2 in the atmosphere is causing big problems for ocean acidification. The Intergovernmental Panel on Climate Change has an appropriate focus on regional changes. In other words, there are global issues, but the panel tends to be focusing on where are going to be the winners and where are going to be the losers. And I think this is very important for planning in helping nature and also helping people. It has an appropriate focus on, everybody agrees that plant productivity as measured by satellites is going up throughout the planet. The areas of green you see have a lot more plant productivity. And the reason why is when you have more carbon dioxide, you can have more photosynthetic activity and the plants benefit. They basically love the elevated CO2. And there is evidence that it increases agricultural productivity in many agricultural plants. For example, warming allows more carbon dioxide that helps agricultural productivity, but it also shifts the belt at which you can grow wheat. So an example of a winner would be Siberia, which right now has trouble growing very many crops, but in the future it's very likely that it could become a very important wheat belt or a wheat producing belt because it'll have a long enough growing season and because of the higher CO2. So there'll be winners in this game of change. Another likely winner in this game of climatic change is South Asia, East Asia, and Southeast Asia. Colder conditions produce the droughts you see here in this slide. Warmer conditions, as emphasized in the third presentation, produced more reliable monsoon rains and no droughts or fewer significant droughts. So winners could be agricultural productivity in Asia. It's hard to say if more tropical rain, which is predicted because you have more evaporation and hence more rain and more instability, would be a winner or a loser. It depends upon the intensity and the location of the rain, but I've labeled it here as a winner. More tropical rain will likely occur. Even though this image is from 2 decades ago, it's an example that the changes that are occurring in the Arctic are much faster than anywhere else on the planet. And it's clear that Arctic ice is a loser, as well as the surrounding land masses would be a loser in the global warming world. Feedbacks are an important concept in science. Feedbacks are basically a snowball effect. You make a change, and that change makes the change happen faster and more intense. You can have positive feedbacks where the change makes the change happen again and again, or you can have a negative feedback where you shut down the change. The Arctic ice situation is a positive feedback. If you reduce sea ice, which is happening from warming, you change the albedo, or the reflectivity of the Arctic Ocean. So you're basically absorbing more sunlight that heats the surface waters. So that means you have less sea ice. With less sea ice, you have less reflectivity, more absorption, and that heats the water even more. So you could quickly lose sea ice, which has been happening. This is a graph showing that the warming of the ocean and the surrounding land is occurring across the Arctic. It's not any particular area, but it's the whole northern region. And it's thought to really get intense and get quite warm by the year 2100. Another loser in the global warming issue would be anybody in any aspect that is close to shore, because sea level is rising. Remember the idea of feedbacks? There is a fear that there can be feedbacks in the way ice shelves work to make them collapse suddenly. So there's a lot of scientific research on the sudden collapse of ice shelves around Greenland and especially Antarctica that could suddenly be released and cause not a gradual but kind of a pulse in sea level rise. So that's an ongoing concern. What I can't stand and personally don't tolerate are blowhard politicians that use scientific illustrations falsely and incorrectly. A famous example is Al Gore, who showed an image of Florida underwater, but that image was produced scientifically in a scenario that wouldn't happen unless you lost basically almost all the Antarctic ice, which is not going to happen anytime in the next several centuries. So it's basically complete misuse of scientific information for political purposes. I don't tolerate it, and I'll call it out. Similarly, I'll applaud decisions by such agencies as NASA, NOAA, the U.S. Geological Survey, to take an appropriate conservative strategy for planning that we should see up to a foot of sea level rise by 2050, which would cause massive problems for coastal cities like Miami. So it's good to use not the low end, not the high end, but the upper high end of estimates of sea level change for planning. Because if you're off and sea level's risen not quite what you thought, the planning still works for a few decades down the road. The biggest concern are areas like Bangladesh that are low-lying with massive population densities. These delta regions are in serious danger because a little bit of sea level rise will cause massive problems for agriculture and where people live. Stakes are high, it's very dangerous, and it's something that will affect the entire world as people begin to move. The agricultural consequences of global warming are tough, definitely winners and losers. The thought is that the lower latitudes will be having the most trouble with increased frequency of weather extremes, the potential for long droughts, increased disease vectors amongst animals. It's just hard to predict and know exactly, other than broadly, the lower latitudes will be in more difficult straits than some of the other latitudes. At least that's the model predictions. If you're the type of person who worries about diseases and other illnesses, you may want to move on. Just realize that warmer temperatures, warmer nighttime temperatures, more tropical moisture will cause more disease and more tropical diseases to be on the move to other locations. Sorry. So moving on from land-based diseases, the real disease problem is not a disease, but a change in the chemistry of the oceans. It increases in carbon dioxide. Carbon dioxide dissolves in seawater, and it forms an acid called carbonic acid and increases the acidity. The acidity causes problems for all sorts of marine organisms. And there's no question that this is human caused. There's complete agreement that humans have pumped carbon dioxide into the atmosphere, and that coral reefs are vulnerable, and that organisms have had a harder time extracting the carbonate they need to build the shells. Here's a very partial list of the winners and losers. Algae have a greater response to more carbon dioxide and acidification, so do diatoms, but calcifying algae do not. Scallops, mussels, oysters, cuttlefish, squid, sea urchins, coral, all these are in a world of hurt, all caused by human acidification of the oceans. With horrible droughts and horrible wildfires, the media tends to blame global warming. I'm not saying that blame is false. It's just not clear whether it's from anthropogenic warming or whether it's from a cycle that would produce mega drought. It's hard to know for sure. Certainly, if you count the number of papers that suggests drought and that associated wildfires are caused by anthropogenic greenhouse gases, that would win. But just because there are more papers doesn't mean it's right. But still, the consequences of drought and fire are so tremendous that it would be stupid for society to ignore the increased issues involved in the anticipated mega droughts and associated wildfires. Regions that plan well will do much better than the regions that do not. You might not think about this, but when you lose alpine glaciers, you create wonderful places for hydroelectric dams. The locations of deeply carved bedrock glacial troughs are often quite good for hydroelectric power generation. So here's some research that shows the potential for hydroelectric power generation in areas that used to have glaciers that are melting. The media and some scientists argue that increased hurricane frequency and intensity are due to increased greenhouse gases and global warming. If you read these quotes, it's from reviews of the literature. It's just not clear. Anybody who stands on a pulpit and says all these nasty hurricanes are from global warming, that's just a religious opinion. If you look at the science, it's just not clear. There's no clear trend in the intensity or number of tropical cyclones as it relates to warming conditions. It might be true, or it might not be. Every year, scientists carry out additional research exploring the impacts of global warming. Here's just a sampling of articles that have been produced over a year period. Late 22, early 23. Unprecedented heat waves in Western North America in June of 2021 due to global warming. Increased risk for extreme precipitation events. Atmospheric rivers being caused by global warming, and lots of tropospheric water vapor with all sorts of chaos. Producing these articles takes a lot of work, but it takes even more work to stop, drop, and test the assumptions of these papers, try and replicate their research, and try and falsify your own research. Because science is about trying to disprove your hypothesis, not trying to prove it. Proof is for math. Disproving something is for science. If you can't disprove your hypothesis, maybe somebody smarter and better can. And if they can't, then we gain confidence in the results. It's not about. There are a lot of ideas on how to engineer a solution to global warming. One of them is to use biology. There's something called the biological pump, which is if you increase the ability of organisms living on the sea surface to absorb CO2, and then they drop out and fall down to the ocean floor, we can sequester a huge amount of carbon dioxide, basically using nature to solve the problem that we caused. This is a serious research proposition that's being evaluated by many individuals, and there are field experiments that have been conducted. Another idea that's been proposed is to put up microsatellites in what's called the Lagrange point. Put out a whole bunch of little disks that can reflect incoming solar radiation. It's a serious proposition made by an astronomer at the University of Arizona a couple decades ago. So there are a lot of ideas out there, but the U.S. National Academy of Sciences convened a panel to evaluate recommendations for geoengineering solutions to global warming. And the panel evaluated and decided to narrow down their evaluation to 3 serious strategies: stratospheric aerosol injection, marine cloud brightening, and cirrus cloud thinning. The idea of stratospheric aerosol injection is to increase the number of tiny reflective particles, aerosols, in the stratosphere to increase the amount of sunlight that bounces back to space. Marine cloud brightening is the idea to add particles to the lower atmosphere to take the low-lying clouds and increase their reflectivity over particular ocean regions that have a lot of low-lying clouds regularly. And the other idea is to take high cirrus clouds and to modify their properties to increase the amount of Earth's thermal long-wave radiation that can make it back to space. These are the 3 serious engineering strategies evaluated in the U.S. National Academy of Sciences report. Ultimately, the idea of these engineering solutions is to try and bring the Earth back into some radiation balance where it was after the climate was too cold and generated droughts in East Asia, but before it gets too crazy. Really, the decision is, if we can geoengineer, what's the right radiation balance for the planet, both ecologically and for people? That decision has not been made. It is my sincere hope that after these 4 presentations, that you take the spin of the media with 20,000 grains of salt. That when you read a media story, understand that it's written by someone like you with just a very beginner's level of understanding of what's going on, and understand that you have a much better perspective because you're looking at it in terms of the radiation balance of incoming and outgoing radiation. And you're looking at it from the perspective of there are regions that will win and lose. So just the media stories may be interesting, they may be amusing, but please don't take them seriously. 24% of those who have been personally affected by extreme weather events in the past 5 years say that extreme weather caused serious health problems for their households, and recent polling indicates that some 60% think that Congress should do more to address global warming issues. One thing is for sure, we are all going to be bombarded with images and stories like this for the rest of our lives. So get used to it and put on your science hat. There's no really good way to end this presentation other than perhaps thinking about what to do. The first 2 bullets, it's too frustrating for me. I can't even think about how I might contribute to international agreements or national governmental decisions. But the 3rd bullet, I do think that ASU and my School of Geographical Sciences and Urban Planning can play a major role. At issue are regional changes. Regions include stakeholders at different scales. There are landowners, there are cities, there are counties, there are tribes, there are other interested individuals. And the missing piece is to have teams of people who understand science, who understand geographic information systems, to be able to portray different scenarios of change and planning, and those with planning skill. These are majors and master students from my school that can go out and say, change is coming. We're going to show you in GIS the range of change we may experience from little to lots. Here is what could happen. Here's a high probability. Here's the timeline. Let's all work together as stakeholders to maximize and make this as good as possible. The 4th bullet of city governments, cities are making decisions to take the power out of the hands of state and national governments and make at least local choices. But really, what I have the most control over are my own personal choice. It's my choice to not use a dryer. I hang laundry on the line because I live in a location where I put it out and it dries within an hour to 30 minutes. It's my personal choice to ride my bike as many places as I can and not use a car. It's my choice to use an evaporative cooler instead of an air conditioner whenever I can. All these things save money and reduce my contribution of greenhouse gases. So, what to do? We can be upset, or we can use our skills, and we can make personal choices. Things for you to consider. I appreciate your patience with all 4 of these lectures, and I especially appreciate your patience with my voice. I'm having issues with breathing that's going to be solved. I have issues that I need to produce these lectures before this semester starts, so I'm grateful for your patience in my voice. Thank you. 3rd bullet, which is to have regional teams to coordinate stakeholders impacted by changing conditions. This piece is needed. We need to have people out there working with counties and cities and landowners and tribes and other interested stakeholders to figure out how best to say, these are the suite of changes that may occur in the next several decades. How do we all not go down the drain? How do we take advantage of this to make things as good as possible? Then there's city governments that have decided to do things all by themselves.